All right, here we go. So you've already seen a for loop, right? You've already seen it in assignment 1, but we never really talked about for loops. But if you read the description, if you read the comment, it explained it pretty well. It's for each thing in a collection of things. That's what a for loop is. So for assignment 1, for each Starbucks location in that collection of Starbucks locations. The loop ran once for each thing. It ran first on the first thing, then it went to the next thing, and then it went to the next thing. And then when it got to the end of that collection of things, it stopped running. That's a for loop. Also, for those of you that had lab yesterday, you were able to play with for loops. Now, here's an example of if I told you to write a function to print, like, and I want to give this string a function. The function's not actually going to return anything. This function's going to have a side effect. It's going to print something out. And I want this function to take a string and then print out each character of the string on one line at a time. All right? So I'm just going to take this code, paste it. I'm going to get rid of the doc string. Oops. There. All right, so that's what that function's doing. And now let's look at the code. I gave it the string hello. Could have given it any string. And it starts with a character index at 0. Well, the character index is less than the length of the string. Now remember, I asked you this last time, but let's just make sure we remember. How long is the string hello? How many characters is it? If I ask the string hello, what would its length be? This isn't a trick question. You should all be able to count. One person can count. What was it? You said, was it 5? 5, yes, because H-E-L-L-O. There's 5 of them, right? See, I told you it wasn't a trick question. Just 5 letters. But if I said, print out the thing at index 5, what's going to happen? We got a problem. There is no index 5 because it starts at 0. 0, 1, 2, 3, 4. The last letter, the O, is at index 0. Remember that. That's important. This is the way it's going to be for the rest of your lives. So character index is at 0. Well, character index is less than the length of the string. Print out the string at index, character index. Well, the first time it's 0. So print out the character at index 0. Increment character index is 1. Is 1 less than 5? Yeah. Print out the string at index 1. That's the E. Increment character index, it's 2. 2 is less than 5, and so on and so on. Right? That's it. Here's a quick little question. It's not a trick question, and if you find this difficult, you're working too hard. Slow down. What would happen if I did this? No, I haven't hit run yet. But what's going to happen when I hit run on this? What would we see? Pardon? So say it again. It wouldn't print the 8. Why? Right, so it starts at 0, we immediately add 1, and then index the string. But I think you're missing something. It would print hello and then crash. And it says index out of range. Well, character index will be 4. We print out index 4, the string at index 4. We go up to the top of the loop and we say, hey, is 4 less than 5? It is. And then immediately add 1 to it. 4 becomes 5. Then I try to index the string at index 5, but of course we just saw index 5 does not exist. So of course that's going to be a problem. That's much better. Now, one thing you'll notice about while loops. Now remember, again, I might sound like a broken record, but it's important. A while loop, the fact that I'm counting here is just because I wanted to count here with a while loop. There is nothing about while loops requiring you to count and check with something's less than something. No, a while loop just needs a Boolean condition. This one, I wanted to count, and I was going to have the Boolean condition based on the count. So I've got a lot of like boilerplate code, for lack of a better term, code that I need there. I need some, I need like all while loops that look like this, all while loops that are going to count will look very similar. You're going to have some variable to keep track of a count. You're going to check while some condition is less than another condition. And then you're also going to have to increment that counter. That's what you're going to need. If you don't increment the counter, you're going to have like an infinite loop. And of course, there's exceptions to these rules, of course. But while loops don't have to count. It's just here I have a while loop that's like counting 0, 1, 2, 3, 4 to index. And all those that are counting will have this pattern. Some variable to keep track of a counter, check that the counter is less than something, do something, and then at the very end, increment the counter. They're all going to follow this pattern. What did I say? There's another type of loop that lends itself. Now, anything you do with a for loop, you could do with a while loop. Anything you do with a while loop, you can do with a for loop. All right? They are not fundamentally doing anything different. It's just the syntax is a little different to make it easier in certain situations. It's just syntactic sugar. A for loop could be handy here. When I said vertical print with the while loop, the only reason we needed that counter was because we needed to index the string. And the reason we wanted to index the string is because we wanted to access each individual character from the string. So we needed a counter to be able to index in order to get the individual character. Okay? With a for loop, it does some of that extra work for you. With a for loop, it means for each thing in a collection of things. A string is just a collection of individual letters, right? Individual characters. So, now mind you, what I put here doesn't matter. That's just a variable name. The first time through the loop, the variable char will take on the first letter in the string, a string. The next time through the loop, the variable char will become the next letter in the string, and so on and so on. But here's vertical print with a for loop. Oops. Okay? The algorithm is the same. It's just one used a for loop and one used a while loop. And which one's a little bit, I wouldn't say the one with the while loop is unclear, but I would say the one with the for loop is definitely cleaner in terms of what the code looks like. Would you agree with that so far? It's a little cleaner. And let's just check it out. Vertical print for. Yeah, and it works just fine. And like I was saying, and pay attention to this, because this confuses a lot of people. What I call this variable does not matter. It's a variable that I just need to use. Of course, you're going to want to use a variable name that's meaningful because you want your code to be good. But the fact that this is called char is not meaningful to the fact, it's not important for Python because the letters are characters. No, I just called it char because it's a character, because I like that variable name. But it doesn't have to be called character. It doesn't really matter. I could call it x. And it's going to work just fine. Yes?
How does that variable get assigned?
What'll happen is, let's go through the code, x. So we start with a string, it's hello. So for x in hello, the first time through the loop, Python goes, okay, x, you are h. You are the first thing. You run the loop, there's only a print. The loop finishes one execution, goes back to the top, there's more letters. X, the Python then goes, okay, x, you're now e. Go into the loop, execute the contents of the loop, just print it out, go back up to the top of the loop, x, you are now L, and so on. That's what's happening here. I'm glad you asked. Any questions about, yes?
I just had a random question that just thought of.
What you're asking would have to be like a very specific, there would be like ways to do that, but it really depends on what you're doing and how you would go about doing it. You mean like, well, what if you don't want to start at the beginning? What if you want to start at like the third letter? Is that kind of what you mean?
I mean, sort of like, I feel like, I can't really think of an example, like, off the top of my head that you could.
If you think of it, let me know, and I'll be happy to chat. Other questions? Anything you do with a for loop, you can do with a while loop. Anything you do with a while loop, you can do with a for loop. They're very similar. It's just the syntax that's different. For loops really are great when you just want to do something for each thing in a collection of things, right? A while loop is really far more general in terms of the condition. So if you have like a loop you want to run based on some Boolean condition, the while loop is going to be the more natural choice. You could probably hack it to work with a for loop, but then you're working too hard. Just use the tool that makes more sense for the job. If you have some Boolean condition that you want to run the loop for, use a while loop. If you want to run a loop for each thing in a collection of things, use the for loop. A lot of times in programming, we're going to be running code for each thing in a collection of things. And we're going to start seeing that more and more. This is just, yeah, explaining it. And then this is just saying, you can call the variable in the for loop. So this variable name is important. This is the variable containing the collection you want to iterate over, you want to loop over. This variable name can be whatever the hell you want it to be. This is the variable that gets assigned a new value each time the loop executes. Here I'm using terrible variable name. You could call it that, but of course you'd want something that's useful. But don't think that because of my example I called it like char, it should be char because it's a character. It doesn't have to be. It's just a good name to use. Yeah?
Okay, so I thought of something like an example. So let's say you have a function that
It's hard to hear you. There's like some fans going, so speak up a little bit.
Okay, I'll try. So let's say you have a loop, and every time you go around the loop, it adds 5 to a variable. Okay, so if you wanted to, like, every second time or so that the loop restarted, you wanted to double the same variable, then would it be possible to have some sort of like...
Absolutely. Without fully understanding exactly what you're trying to do, I would say you could do that by having like nested loops, where you run a loop 4 times, and then you run that loop 5 times. So if you have a loop that's running 4 times, but you're doing that 5 times, how many times is that code on the inside actually going to run? 20. So what you could do is like, okay, run it 4 times where you're adding 5, and then the next time make it add 10, and then the next time add 20. Yeah, you totally can do that type of stuff. So here's an interesting thing about strings. If I go down here and I saw some right? No big deal. I can access an individual character. I'm good to go. This shouldn't really be blowing anyone's mind. I'm saying, give me the character at index 1. Well, that's the E. Now, this then might make you think, now this is with strings. This is not the same with lists, which you saw in assignment 1 and is in assignment 2, and we're going to talk about a lot more very, very soon. But with strings, you might say, okay, if I can access some string at index 1, in a similar way where I could say, okay, A equals 5, print A, right? No big deal. And then I can go A equals 6. This shouldn't be surprising to anybody. You know, I went to A and changed its value. So with this idea, can I do this? This is saying, go to the string at index 1 and make it an x, right? I just showed you I took the variable a and replaced its value. Here I want to go to some string at index 1 and replace its value. Is my goal clear? If this worked, I would see HXLLO printed out. So I hit run, it doesn't work. String object does not support item assignment. This isn't going to work because strings are what we call immutable. You can't change them. That's what that means. And this you might think, oh, it's a restriction. I don't like restrictions. That's usually the wrong mentality in programming. When things are immutable, they're a lot easier to work with. They're a lot easier to reason about. It's a lot easier to not make mistakes and avoid bugs. So we like immutable things. So don't think, oh, that's annoying. We can't do this. And we could talk about why we can't do this in a moment. But let's say you say to me, but I want to do that. I really want to be able to go do that. My answer is you can't. You can't. You can't go to a string and change its value. And here's why. Imagine I have a string. When I had the variable, think of it like this. When I had the variable 5 and I replaced it with a 6, here's what happened. There was a number here, right here. There was a 5 sitting in this chair. All right? And then when I said, okay, become 6, I went here and I made it a 6. No big deal. But remember, strings are a little funny. They're a little different. If I have the string hello, I've got H-E-L-L-O, right? And let me show you another thing real quick here. I can change what some string is, but I can't change something about the string in that variable. So I can say some string you're hello, some string you're now world, but I can't go into the string and change anything about that string. So like with the integer, there was a 5 in here. I replaced what was in that variable with a 6. That's what I did there. When I was trying to go into the string and change something about the string, I was actually trying to do something quite different. I was trying to go into a string that existed and change something about that string. I can change what's in the variable. In that variable, we have a string. I can't go to the string inside the variable and change something about it. This might not be a clear difference, but it's going to become a lot clearer over the next few topics when we start talking about linear collections more. So I'm not allowed to go inside of a string and change it. I can change what the variable is referencing. The variable has the string hello. Now it has the string world. But I can't go to the string hello, open up that string, and change anything about it. That I'm not allowed to do. Then you say, what if I really want to do it though? You're saying I can't, but I really want to. I still say you can't do it, but here's what you can do. You can make a new string based on the old string with the change you want. So here, for example, in fact, here, I'm just going to reassign it too. Here I said a string is hello world. I printed out a string. Then what I said, okay, let's make a string with the first 5 characters of the original string. Then I want to concatenate it with the string exclamation point. Then I want to concatenate it with the rest of the string, the original string. This makes a new string. And then I put that new string back into a string and I print it out. I can perhaps make it even clearer. Here, I didn't put it back into a string. I created a new variable, b string. First, a string is hello world, print it out. That's the first one. Then b string is that new string based on a string. Print out a string again. We can see a string is left alone. Nothing about a string changed. It was just that we created a new string based on a string to store into b string. Any questions about this? All right, linear search. Yes?
Can you do the reassignment in integers?
Well, so here's where, okay, can you be more specific?
Like if I had numbers instead of hello, can I change the second number?
If the numbers, so this is an interesting question. If the numbers are a string, though, the answer is no. If, here, where, give me a second here, let's see. Okay, I'm going to give you a spoiler for the next topic. If, however, we had something like a list, okay, like your Starbucks, yeah. Here, you know what? Now, if it's a list is mutable. We can go in and change something about it. But that's actually because lists work a little, they're different than strings. There's like an engineering reason why they're a little different. But if it's a list, now here I did it with strings even, but I can go in and change what's at the index of that list. But we're going to talk more about lists next topic, so don't get too worried about this. Other questions? That was a good question. All right, so here is a common problem. If you were to ask me what's like the biggest, like what is the culmination big takeaway of 161? If I were to say there's like one algorithm that if you're an expert on, you did very well in 161, I'll say it's linear search. All 4 of the assignments really are based on linear search. We're going to talk about linear search very explicitly here. But the idea is, now when I say all 4 assignments are based on linear search, it's not an explicit linear search, but it's like a variation of the idea. So here's the problem. I say it's an activity, but I'm going to do it so we can kind of do it together. Can that please go away? Why is this? All right. Here's what I want. I'm going to give you a string. Or I'm going to give this function a string. And I want to know if a given character exists inside that string. If it is there, I want the function to return true. If it's not there, I want it to return false. And you know what? No, I'm actually going to give you like 5 minutes for this one. I want you to try this one. Now, when I said this is the most important thing of the semester, to be clear, if you don't know it right now, that's what I'm expecting. So if you get it, great. If not, no, don't think that you're not getting it. If by the end of the semester you don't know this, you're in trouble. If you don't know it today, you're normal. Though you have absolutely, absolutely all of the skills, you've learned everything you need to know in order to do this. Is anyone done? One? Okay. I'm not rushing you, I'm just curious. If it wasn't obvious, haystack will be the string and needle will be the individual character we're looking for. If you got it backwards, it doesn't matter, but you know, we're looking for a needle in a haystack, right? Raise your hand if you're done now. 2 people, 3 people. Raise your hand if you think you'll be done in just 1 more minute. Okay, take the minute. Does anyone's look more or less like that? Raise your hand if it does. Well, you're wrong.
The L's should be outside the border, outside the statement.
Yeah. You're wrong. You didn't even test it then. Look, if it's like this, it's going to fail. First of all, there's that one that's going to fail. But it'll also fail on that, and my goodness, you didn't even test your code then. Now, don't worry, we're going to talk about why it's wrong. But this is, I would say, this is, that error is, when it comes to linear search, that is the most common mistake new programmers make. So if you made that mistake, I was expecting half of you to make that mistake anyway, so I was being mean. But let's think about this for a second. I want to find if a given character is in some string. First of all, let's talk about this algorithm for a second. It might seem like a bit of a... Let's think about the problem, or let's think about the algorithm in English. If I gave you a stack of papers, has anyone in here ever received a stack of papers before? Maybe it was a stack of assignments or something, and you wanted to find yours in it. Has that ever happened to you? Put up your hand. I know it's happened to you. Give me a break. Of course. And how did you do it? You start by looking at the thing on the top, right? Does it have your name on it? If it does, what do you conclude? What have you found? Well, the thing you're looking for. If it doesn't have your name on it, what do? You go to the next one. If that has your name on it, great. If not, what do? You go to the next one. Yeah. You've all done this before. You've all done a linear search. You just probably never really thought about it in terms of its like steps like that. You just did it. But you know a linear search, whether you like it or not. You've all done it. And if you made that mistake I was talking about, I'm willing to bet you wouldn't have made that mistake in real life. Let's go back to the wrong code and talk about what this means. We have needle, haystack. All right, for loop. Current character is going to start at the first letter in the string. So I have this, let's say I have hello, right? And I'm looking for A, let's say. I would go, okay, current character is H. If current character H equals A, needle. A is needle, it's the thing I'm looking for. I ask, is H equal to A? Help me out. False. So I don't return true, I return false. But remember, first of all, whenever a function hits return, it stops right there. If you have an else with the return false, all your code will ever do is look at the first thing in the pile. That would be equivalent to you taking a stack of paper going, my name's not on the one on the top, therefore I must not be in here. Who would have done that in real life? No one. That's silly, right? No. I can conclude the problem is, does something exist within this collection of things? All right? Does needle exist within haystack? I can conclude that needle does in fact, now listen up, this is the big thing here, linear search. This is basically 161's algorithm. This is your first general purpose algorithm. Every line of code you wrote before was part of an algorithm, but this is your most general purpose. You're going to be writing this a lot. A lot of code is just linear searches. It's simple, but it's not trivial. And the reason we like it as programmers, as a way to start teaching people, is because it gives us a chance to think about the problem and think about our algorithms a little bit more explicitly than perhaps we have before. You've all searched for something before. So you're all familiar with this problem. So, does needle exist within haystack? I can conclude that needle does in fact exist within haystack as soon as I find it. I might have a haystack of a billion things. And if I find it on the third look, do I keep looking? No, I don't need to, at least. I found it, I'm done. So the moment I find the thing I'm looking for, I can conclude it's there. But I cannot conclude that the thing I'm looking for is not there until when? Until I've looked at everything and confirmed none of those things were it. So that's why, like you said, we had to take that return and put it outside of the loop. The loop is going to run for each thing. If we find it for any iteration of the loop, let me put it back to the correct way. There. If at any point in the loop we find what we're looking for, we return true. We stop. We're done. But if the loop ever finishes, let's think about what this means. If the loop ever finishes, that means we got to the end of haystack. And the only way we could ever have that loop finish is if we hadn't returned true yet. And the only way we haven't returned true is if we never found what we were looking for. And if that's the case, then we conclude it's not there. If I gave you a stack of papers and said, find the one with your name on it, if you look at half of them, can you conclude that you're not there? No. If you look at 99% of them, can you conclude that you're not there? No. If you look at all of them but one, can you conclude that you're not in there? No. You have to look at every single one before you can conclude. The moment I find the thing I'm looking for, I know it's there. I can only know if the thing I'm looking for is not there if I've looked at everything. And this is critically important. And if you're thinking to yourself, yeah, obviously, all right, fine, I'm going to see you mess this up a bunch. That's okay. You're supposed to make mistakes. But don't think this is trivial. Okay? It's important to take your time and understand these things. And here's what's fun about linear search. If I gave you a haystack of, if I gave you a string of length 100, and I told you look for the letter A. It's an arbitrary string. You don't know what's in there. But you're looking for A. It doesn't matter that it's A, I just picked A. Best case scenario, what is the best case scenario in that, in terms of the amount of work that you're going to have to do? I gave you a stack of papers and I tell you, find the one with your name on it. What's the best case scenario for you? It's the one on top. How many things do you have to look at? One. Great. But what's the worst case scenario? The bottom, or not even there. It might not even be in there. Whether it's the bottom or it's not there, how many things do I have to look at? All of them. Yeah. If there are 10 things, how many things do I have to look at before I conclude it's not there? Come on, wake up. Give me a break. 10. If it sounds like I'm making it sound like you're in elementary school with simple questions. I'm not. These are simple questions that have big impacts, okay? You have to think about these things, because this is what computer science is. If I give you a haystack with 100 things in it, how many things do you have to look at, worst case scenario? Yeah. What if I double it? How many things do you have to look at? 200. If I multiply it by 10, how many things do you have to look at? Yeah. If I gave you a list of n things, where n is some arbitrary number, how many do you have to look at? N. If I doubled it, how much more work do you have to do? Twice as much work. This is an example of what we call a linear time algorithm. It means the amount of work that algorithm has to do, in the worst case, we often like to think about worst case scenario. The amount of work that algorithm has to do, worst case scenario, grows linearly with the size of the input. That is just, if you don't like the math words there, all that means is if I double the size of the input, I have twice as much work to do. If you quadruple the size of the input, you have 4 times as much work to do. That's what it means. The amount of work that this has to do grows linearly with the size of the input. There are problems out there, though, that are wildly different, and algorithms that we have for these problems that are going to work wildly different. Raise your hand if you've ever sorted anything before. Put up your hand. Give me a break. My 3-year-old can sort blocks. You can do it. You've all sorted things. You know what's funny about sorting? Is chances are the way you've been doing it, there are better ways that we'll talk about near the end of the semester. But that's an example of a quadratic one. A polynomial time algorithm where the amount of work that the algorithm has to do, the amount of work someone sorting something has to do grows like n squared. If you double the input size, you actually have to do 4 times the amount of work. That, for those sorting algorithms that you've probably been doing, the more you have to sort, it gets way harder, faster than something like a linear time algorithm, like a linear search. There are a lot of algorithms out there that have a variety of different complexities that we talk about, runtime complexity. This one's linear. I told you an example of a quadratic one. There are some that are logarithmic, which if that scares you, don't worry, computer scientists do log base 2, which is it's the easiest one. There are some that are crazy. You know what, there'd be a way to do this. There'd be a way to do like a search where it's actually constant time with a bunch of asterisks, but we'll pick up here next time. Anyways, any last questions before we end? All right, and yes?
Oh, if the variable is forever long, doesn't that take?
Okay, that's an interesting question. So that could be, you know what, ask that again next time, because that's a good one. That we can sink our teeth into it. Good one. But remember, everybody, come to student hours if you have questions, thoughts, whatever, want to chat. See you later.